and you can see a description right beside it. My problem was creating enemy AI. Then I could see different people who had opened similar cases. Then various contributors gave advice on how to solve those problems as well. So we go on to the third tip, which is adding comments to your code. Now, from our first class, we talked about how to apply this by using your double forward slash and typing in your comments. So comments make code very easier to read with and work with. If you were to take a break from your projects now and you were to resume next week, adding comments would make it easier to pick up from where you left, and you can easily see what you had assigned a block of code to, like the particular function you want that block of code to execute. And if there's an error there, you know that that is what is not being executed. So you'll be able to correct everything easily. So basically, organized code is easier to read and work with. And also when you're working with a lot of people, adding comments to your code makes it easier to read and understand, also work with. So we'll be moving to the fourth tip, which is the use of version control apps. So this basically helps to recover previous functioning projects. You publish your projects when beta A of a project works. So you publish it to GitHub so you can continue working on the project. Eventually, if you run into problems that you cannot solve, you can go back and recover the beta A working version and continue working with it. I have also embedded links. There are different version control apps, but the most popular ones for Unity are GitHub and Perforce. I've embedded a link here, so if you'd like to know more about version control apps, you can go through the link in the slide. And finally, it is advisable to not congest your scripts. If, like we'd be working on today, we're working on an endless runner game, you have a script for movements, you had a script for spawning your background, your ground, you have a script for spawning obstacles, you have a script for your coins. So you shouldn't put all those scripts. So you shouldn't jam everything up in a single script. Anything could go wrong. So it's better to create a separate script for each thing you want to do. It helps with organization and helps with it makes finding problems easier too. Then the final tip would be to take a break. See, you could literally sleep or drop your project overnight, sleep and wake up, and you see the solution to that problem sitting right in front of you. So taking a break, having some time away from your laptop or computer could help you to easily comprehend those problems and find your solutions. So far, do you have any questions to ask, or am I going too fast? You understand what I've been saying? Can you guys hear me?
Yeah, I can hear you.
So do you guys have any questions or problems?
No,
So you understand everything I've been saying so far?
yes.
Okay, good. So let's get right into the main agenda of the day. So today we're going to be creating an endless runner game Unity. Let's run Unity immediately. So all you have to do is open Unity Hub, then click on New Project. Then we've done this in the last couple of classes, but I'm going to go over it again. You click on New Project, then you create a 3D project, you rename it, and click Create Project. It takes time to compile, so I'd already created a project before this class, so we could get started with it. So let us get started. First off, we want to create an endless runner. What do we expect to see? We expect to see our player moving forward continuously and unendingly. The player continues to move forward except he runs into an obstacle or he falls off the track. So we expect obstacles. We need to spawn obstacles. Obstacles, we can't arrange them manually rather. So we're going to create a script to spawn those obstacles in random positions. Then next up, we need coins. The game would be more interactive if the player had something they were picking up while dodging the obstacles. So yeah, coins make it more interactive and more interesting. Then finally, in addition to those coins, it wouldn't make sense to just keep on picking coins without having a counter. I'm going to work with UI, a bit of UI to create a sort of like a text counter that shows the number of coins the player has picked while playing for that period of time. So first off, we're going to be doing most of the stuff Michael had already done in the last class. So I'm going to go through it very quickly. We're going to create a plane, a 3D object, and a plane, and we're going to rename it ground. That is where the player would be moving on. Then next off, let us reset this. We're going to set the scale on the z-axis to 10. That is to extend it. Scale on the z-axis to 10. We want it extended. Then we set the z position to 40. Next up, we want our camera to view it, yeah, just like this, but we want it more top down. We want a more top down look. So we're going to click on our camera, then our Z position on the camera, we adjust it to -5. And we adjust the Y position to 5. Sorry, my mouse is a bit switchy. So we want a top down look, and we rotate down to 30. Sorry, rotate down to 30. Okay. So this works for now. Then next up, we want to create our player itself. So we're going to be working with a 3D object, and we'll be creating a capsule. Let's go back to our scene view so we can see what we are working with. Then we reset the position of the capsule so we can see it in the scene view. So let us rename the capsule to player. The next up, I want it to look a bit skinny, so we're going to scale it on the X and Z axis by just removing 0.1. So we're going to have 0.9 on the X axis. Let me move in a bit closer, and we're going to have 0.9 on the Z axis. So I want the top of the plane, like I want the player to stay on the top of the plane. So we're going to move the position on the Y to 1. Sorry, my mouse is a bit switchy. On the Y to 1. Yeah. And on the Z and X to 0, just so it stays on top of the plane. Now it isn't directly touching the plane because we've scaled down the X and Z to 0.9. So next up, we are going to be, of course, as discussed in the last class, we're going to be interacting with other bodies in the game. So definitely the player must hit the obstacle. We have to add a rigid body component to this player. A rigid body, you could search for it, RIG ID, because we'll be working with more physics here. Then let's see how the player interacts with the ground now. So hold on. My panel is blocking it. Okay, let's see how the player interacts with the ground. So you can see that the player drops onto the ground, which is what we are looking for. So we don't want a case where if the player hits an object and it slants over a side, it falls. We don't want that to happen. So we're going to freeze the rotation constraints. Hold on, I'm going to put it back. We're going to freeze the rotation constraints in the rigid body component. We freeze X, we freeze Y, we freeze Z, so the player will not tip over. Then next up, we want to give the player a personalized look. We're going to create a new folder. and we call it materials. Per folder, and we create a new material and we call it player material. So in the player material here, we go to albedo, then we change the color to maybe blue. Okay. After that, we assign our material to the player itself. So you can see that now. So next up, we want to create a script to move the player around. We know that the player is going to constantly keep moving forward, and we know that we're going to need some horizontal inputs to move the player left and right. So we go into our folder, our assets, we create a new folder and we name it scripts. Sorting these things out makes organization easier and it helps having a neater workspace. So we create a new script, a C# script, and we name it player event. So let's open up the script, give it some time to compile. So open up our script. Okay, let's hold on a bit. So our script is opened up. Like the last space shooter game, we knew that we have to move the player at a certain speed. So we create a new variable speed, the float. So create a public float speed. And for now, let us keep the speed at 5. Then next up, we're working with rigid body, so we have to create a new variable. So a public rigid, name it RB. Okay, so now I'm going to create a new function. We've been working with the regular update function in previous classes, but now we want a situation where we want to run the code, the script rather, at a fixed interval. That is, we want the script to run every second. Using an update, the regular update function will make the script run every frame. So we want it to run every second. So what we are going to do is we are going to create a new function. So it's going to be a private void fixed update. Then Unity automatically creates it for you. So now we want to move the body forward. It's a 3D runner game, an endless runner game rather, like Temple Run. So in Temple Run, okay, hold on, let me add the person to the class. About that. Okay, so since it's here. Okay. So in Temple Run, we know that the player continuously moves forward. So we're going to create a new vector 3. Call it a vector 3. And say move forward, a new variable. And we say transform does forward, I used to move it forward. Transform does forward multiplied by our speed.
I can't see your screen.
Okay, hold on, sorry. Hold on. Okay, screen. Okay, can you see my screen now?
Yeah.
Yeah, I can.
Okay, so we're going to be creating a vector 3 variable and we name it move forward. So first of all, we want to get the forward on the transform component. Then we multiply it by speed. Then time. At a time, because we want it to update every second. So now next we're going to move that rigid body. So we say rigid body rb.move position, then your rigid body, getting the position of the rigid body, plus your move forward variable you created earlier. So now what this does, this guy just moves your player forward continuously. So next up, Michael, are you here? So you can add people, okay? Okay, next up, we want to.
Don't worry, I am allowing them sake of interview teaching.
Okay. So next up, we want to receive inputs from the player, the horizontal inputs. So we go down to our regular update function, and we create a new variable, call it horizontal inputs. Equals to input, input get axis horizontal. So call it horizontal. Then back in our fixed updates, we are going to create a new vector 3 to move this sideways. So we call it a vector 3. Move sideways. Also transform dot right by your horizontal inputs. Okay, so we're going to make this public. Horizontal inputs. Then this multiplied by your speed. And finally, time dot fixed delta time. Okay, seems I've created a problem. Hold on. Update input back repeatedly. So we see a problem. Point update method. Okay, let's see. Since I run into a problem here, page does get access. That's horizontal. Don't save our scripts and move into the game. Okay, so finally, what we have to do is move position here. So say rigid body dot move position rb dot position plus forward move forward, then plus your move sideways. Let me close it. So over here I've made a mistake where I Hello? Can you guys hear me now? I am sorry.
Hello? Yeah,
Can you
I'm
hear
with
me?
you.
Oh, sorry.
Yeah.
And it's connected. Okay, so we say horizontal input equals to input as case axis. Then we don't need this script here. So finally, what's this error? Say the name horizontal input does not exist in the this context. So instead of bringing this out, we can just actually.
You didn't collect you didn't create horizontal input as a variable.
Oh yes, I am sorry. I am sorry about that. So let's see. So we say public. If it's rather good, I'm calling horizontal input. Sorry about that. Then we can move on now. So after this, we are to move the rigid body to the position we set. Then let's go into Unity and see how it looks now. So we save our scripts, go into Unity. We have to assign our player movement script to the player. This thing is blocking my view. I have to minimize. Okay, let's go ahead and play to see how it works. So the player and our script player rigid body add it here. So we can see the player moving and receiving our inputs. Next up, we want the camera to follow the player. So let's get started. We stop that. Sorry, I'm going too slow. We create a new script and we call it camera follow or follow player camera follow. Next up, you open your script. Let's wait for it to compile. So we create our variables public and call player. Next up, we create a new vector 3. This is just axis of the offset. Vector 3, then offset. Next up, we want to initialize, or when the function starts to run, we want to get the offset, that is the distance between the camera and the player itself. So we're going to create a comment. So we say keep at a distance the player at all times. So we say our offset goes to our transform, that is present position minus the player position. So after this, we go into our update function and we create a new vector 3 for the target position. So we say vector 3 and target position. So we've done this in the last couple of classes. That's why I'm going through it. equals to our current player position our offset. Then target position x equals to 0. We don't want it to stay player. We don't want the camera to move on the x-axis. If the target position is x equals to 0, and finally we store the current position into the target position. So transform to target position. Well, let's save our script. Go back into Unity, wait for it to compile. Then we add a camera follow script to our camera. Then we've created a variable for the player. All we need to do is drag and drop the player into that empty space over here. So let's check out our scripts, our code, see if it works. As you can see, the camera is following the player. I will open a better view so we can see it clearly. Okay. Let's use default, but we open our scene view. Got the game here. Okay, so we can see everything working in real time. So let's run our script. You can see the camera follows the player as he moves. So next up, now let's get into it. I think my screen is frozen. So we want to create a spawner for the ground. Right now, we're limited to just one platform we've already created. We want to create a code to place a new ground in front of the player as the game moves on. So how we're going to do that first, we're going to create a new tile that will spawn continuously in front, and definitely we'll have to destroy the ground tiles that the player has already passed, so there isn't congestion in our hierarchy. So next, we're going to create a new plane over here. Create 3D objects. Let's create a plane, and we call it ground tile. So then, sorry. So let's delete the present ground. So we create an empty object and we call it spawn point. Okay. Create an empty, we call it spawn point. Perfect. Okay, I'm sorry, I made a mistake here. Let us create. All right, sorry guys. First, let's create an empty object and we call it ground tile. Then next up, we right-click on it, we create a new 3D object in it. And we create a plane. We make the plane the child object of the ground tile. Then we call it a plane. And the plane is a ground object, a child object rather, of the ground tile. And we set the Z position of the plane to 5. So just right at the beginning of where the player starts moving. The next up, we right click again, we create another empty child object inside the ground tile, and we call it next spawn point. And we change the C position of the next spawn point to 10, just so it is on the edge of the end of this tile. See in our scene view, right on the edge of the tile. Now, so we create a new CryptFab folder to store this new ground tile in, and create a new folder, name it prefab. And we open up our folder and we drag the ground tile into the folder. Then we can go ahead and delete what the ground tile presents in our hierarchy. Now we want to create a new script called ground spawner. This is where we put the instruction and the conditions the ground tile that is to be spawned. Go ahead and create a new C# script and call it a ground spawner. So let's wait for it to compile. Sorry. So open up our ground spawner, and we want to create some variables, new game objects. We make it public so it is accessible down the line when we're using it. So we say public game object, and we name it ground tile. Next up, we want a new vector 3 for the spawn point. So we call it next spawn point. Be disoriented. Go ahead and save our script. Okay. Ground spawner script and name. So now let's open up our prefab. So in our hierarchy here, we create another empty and we call it a ground spawner. Now we add our newly created ground spawner script into, we assign it to the ground spawner game object we just created. Then we go into our prefabs. Then we drag and drop the ground tile we created into the empty variable here. Cool. Now let's go back into our script. Our spawner script. Then we create a new function. So let's call it public void and call it spawn tile. Curly braces. Next. So now we want to spawn the ground tile at different variables. So we're going to use the instantiate. Instantiate is basically Unity's own way of saying spawn an object. So we're going to instantiate, Then first thing we're going to put in is the object you want to spawn, and the object you want to spawn is the ground tile. It's a ground tile, then comma. The next thing we put in is where we want to spawn the object. So let us put that at the next spawn point. And finally, we're going to use a quaternion dot identity. So what this basically does is it doesn't rotate the ground tile after spawning it. So now we need to set the next spawn point. To do that, we need to reference the child of the object we just created. So now we're going to add a game object into, so we reference it here. So we'll say game object is for temporary equals to this. Cool. Now we created a variable temporary, that the variable name temp for temporary. Then next up, back over on top of here, we create a new variable. Rather, we continue coding here. Our next spawn point would be equals to temp transform get child transform dot get child. Then we want the index of the next spawn points. So we could go back into Unity, open our game tile prefab. Then, as you can see, we have two here. The plane, the index of the plane is 0. Counting positions in C# starts with 0, 1, 2, and as we go on. So here, plane is 0, while the index of the next spawn point is 1. So we go back into our script. And we say temp get child 1, that is the first one. Then dot transform to get the position. So cool. Then after this, we go to our stats. Then we call the spawn tile. So it runs every time the game is started. And let's go ahead and save our script and see how it works. So let's play. So as you can see, it spawns just one. It spawns one. So let us do it 5 times to see how it would look. So we call spawn tile 5 times from now. This isn't what we'll be doing. We have to create a loop. But let's see how it works this way. So when we press play, you can see that 5 ground tiles are spawned over the next 5 start points. Cool. So now we create a loop, and for this we'll be using a for loop. So instead of using this, we'll say for. For the length, we simply replace length with 15. We want this code to run 15 times. Then we call spawn. And let's save our game, our scripts, and check out how it looks in the game. Hold on. Okay. I'm having a problem. Okay. So we can see it spawns 15 times, and we can move our player and interact. So we notice that this comes to an end. Then definitely we need to spawn the tiles as the player keeps moving forward. And for that, we need a trigger on the ground tile that will call a function when both the player overlaps it and when the player leaves it. So we need a trigger to know when the player passes it and when the player leaves it. So when the player leaves the collider, we spawn in another tile. So to do this, let's go to our ground tile prefab. So we open up our ground tile prefab. Then we select the parent, that's ground tile. Then we add a component. We add a box collider to it. We say box collider. Then we click each trigger, just so we want to be notified when the player is on the platform and when the player is off the platform. So you click each trigger, then we set the size on X, Y, and Z to 10. The regular size of the tile we're working with. So 10, 10, 10. Coming, the plane. 10, 10, 10. Hold on. Then see the size. So 10 on our C. I'm coming. We have to. So let us open the edit the collider. I'm using my trackpad because I'm having problems with my mouse. Let's see how this looks. Okay, perfect. So let's just change Z position to 5. Then my screen is frozen. Okay. 0 changes to 10. So we create a new script called ground tile. Go to our script folder, we create new C# script, call it ground tile. Hold on while it compiles. Let's open up our scripts. Our first thing we're going to do is create a variable called ground spawner, and we name it ground spawner. Basically, this variable is to reference stuff from the earlier scripts we used or we created rather. Then we're going to set a reference of this in the start function. So we go to our start function here and we say ground spawner be equals to, so we want to find the game object dot find of type rather. So we say find object of type and use our brackets. We want to find the ground spawner. So we say ground spawner, then parentheses and semicolon. Good. So now we create a new function for on trigger exit. That is, this trigger, this is what checks for when the player has left the ground tile we're working with. So we say on, we say, let's say void on trigger exit. Private void on trigger exit. We got the ground, we found ground spawner dot spawn tile, as is spawn tile in the ground spawner. Really, the reason we can access this is because we made the spawn tile function, the ground spawner earlier public, and we have already referenced it in this script. So we call it here. Then we want to destroy game objects. Okay, say destroy bracket game object. Then we destroy the game object after every 2 seconds the player passes the trigger. Good. So let's save up our script. And we go into Unity. So we add our script to the ground tile prefab. So you could easily go here, click on your ground tile, add components, then you search for the script. Script's name is ground. So let's check out our code. You can exit this by clicking here. Let's zoom out to see how this works. So learn that clear. You can see that the script is being destroyed after every 2 seconds when the player has left the ground tile, and it's being respawned in front of the player as time goes on. So basically we can maneuver with our player like this. So let us make the ground look more like a ground. So for this, we could just Google a texture. Then I have already downloaded, but let's Google the texture. We're going to Chrome. Done. Sorry, I'm coming. I'll share my screen now. Sorry, hold on. Okay. Share screen. Okay, cool. Let's minimize this. Having problems with this start by height. So create a new window. Then we say brick ground texture. Brick ground. So we could download any one you think you find attractive or you don't want to use. So let's check this one out. So we can download this. So let's open this. So save image as. Hold on. Hold on. So let's call it ground tile. Then we've downloaded it. So we go back into Unity. Then can you guys see my screen? Can you see my screen?
Yes, we can see it.
Yeah. Okay. So let's create a new material. Create material and we call it ground map. So we open up our, just beside our window, you can see this, you can use it to, this little circle, you can use to import stuff we already put in the assets. So let's put that ground tile we just downloaded into our assets folder. So we go to desktop, downloads, then import this. You can see it's been imported. So all we need to do is click on this little circle in our window, select the ground tile. So let us assign this material to the ground in the ground tile prefab. So we open up our prefab, materials, ground map. Then we add it to the plane. Good. So we can rename this plane to ground just for clarification's sake. Okay. As we can see here, we have our ground texture. Let's see how that plays out in the game. We can go ahead and click play. You can see it has the texture. Then finally, I noticed something. Every time the game starts, it seems like the player is on the edge of this. We don't want to see this gap while we're playing the game, while the game starts. So what we are going to do is we select our player. Select our camera and we select our player. Then we move them about, let's say, 5 minutes to the front. Let's see how that looks now. Let's go ahead and play. So you can see the gap is no longer there. So we can work with this. This is fine. Oh, I think I went a bit too far. So let's control. And let's play again and see how it looks. So we are working with an exposition of, let's say, 5. Okay, 5, 10. 10 is fine. Good. We can see 10. So close this. So Control C. And we save that. Yeah. And we move it right about 10. Let's see how this plays out. Yeah. Let me zoom in now. Okay. Okay, I think this is fine. So let's play and check. So after this, we are going to be spawning obstacles into our game to make it a bit more interactive. Okay, this is fine. See, I have a lot of tiles here. Let's work with what we have so far. Okay. So we want to spawn obstacles in random positions. So first thing we want to do is we open up our ground tile prefab. Then we create an empty game object and we call it obstacle on left. Now let's set the position, reset the position first. So we set the position on the X to minus 3.3, just a third of our working on space. Then the position on the Y to 0.5, so it is slightly above the ground. And finally, position on Z to 10, as on the other edge. Good. So now we'll duplicate these 2 times for the middle and for the right. So we duplicate this, Control D. We call it obstacle spawn middle. And duplicate this again and call it obstacle spawn right. Okay. Let's set the position of the X on the middle to 0. And for the right to 3.3. Good. Then we exit our prefab Then next up, yeah, fine. So I'd like to move this back a bit. See, that is good. So good. Then we create a new cube for the obstacle. Hold on, let me check the game. I'm trying to fill that gap. Okay. We have a lot of room here. So I mean 1, 2, 3, 4, 5, 6. Good. Okay. So let's in kind of a player. So we can move it. So around here. Perfect. So let's create a new 3D object and we add a cube. So let's rename the cube to obstacle. Then we reset the transform. Reset. Okay, okay, now I can do this. After resetting the transform, we set the position on the Y to 0.5, the position on the Z, and we scale the Z to 3.33. Okay, that's fine. Okay, we can't work with this. Let's set it to X rather, so to Z, and our X we have 3.33. Then we add this to our prefab folder, obstacle to the prefab folder, and we delete this present one from the scene. Perfect. So let's create, let's just open our ground tile scripts. Ground tile script. Then we're going to add a new variable for the game object. I'm going to call it a public game object and call it obstacle prefab. Then let's save this. We open up Unity. Hold on. So go to the prefab folder. Then we open up the ground tile prefab. Then we can see there's an empty variable spot here. So we feed that in with obstacle. Good. So we go back to our script. Go to our script. Then we create a new function and we call it void. Use void. Call it a spawn obstacle. Braces. So for this, we're going to choose the random point on obstacle. So per index in the ground tile prefab, let's go ahead and check that in Unity. In the ground tile prefab, the obstacle spawn left is the third here. So we have 0, 1, 2. So it has the index 2. It is the third child object of the ground tile, but per index is Unity, we're going to call it 2. While the middle is the 5th and the left is the 4th. So here we're going to say create an integer for that index. So we call it obstacle spawn index equals to, so we want to put a random dot range. You see random dot range bracket, this 2 to 5. This gives us a random number between two inputs, including the first one. So it's going to give us 2, 3, and 4. It excludes 5. So good. So let's open this out. Yeah, so this is good. We transform, create a new transform. And call it spawn point. Supposed to transform. Explain what this does after this. Dot get child. Spawn index. Then dot transform. So what that does is that it just returns the transform components of any of the 3 optical spawn points we've created. So next we are going to add a new comment. We want to spawn the obstacle at the position. Sorry. The obstacle at the position. Then for this, we are going to use the instantiate. So you see instantiate. First of all, as we discussed earlier, we are going to get the what we want to spawn first. So, and that is the obstacle prefab. Then secondly, we want the position we want to spawn it. Then we want to limit rotation. So what we want to spawn first, that's obstacle prefab. The position we want to spawn it, spawn points, dot get the position of the spawn points. Then our quaternion index, quaternion identity rather, that's to limit rotation, and finally our transform. So let's see this up. Now in our start function, we want to call the spawn obstacle. So we say spawn. Good. So let's save this and go into Unity, see what we have right now. Sorry about that. Hold on. So have you guys been understanding what I've been doing so far? Hi guys. Hi, anyone? Oh, okay. Let's check out our game and see how it works now. So there we go. So you can see that that's random points. Good. So we can go ahead and increase the player script. It's too slow. So let us increase the player speed to 10. Okay, so just hold on. I want to increase the horizontal movement. I want to increase the speed of the horizontal movement. The horizontal speed shouldn't be lower or the same as the forward movement. So what we do is go back into our player movement script and we create a new float. We say a public float horizontal higher equals to, let's give it a 1.7 f. This is good. So in our move sideways here, we multiply by horizontal multiplier as well. So after our horizontal inputs, we multiply by horizontal multiplier. And save our script. That's how. So we can also save our script here into Unity. Let's see it compile. So remember I said I want to increase the speed of the player. So let's click on our player, then go to speed and put 10. So let's see how the game plays out now. Okay, I think it works well. Then we notice that when we hit the obstacles, nothing is happening. Nothing is going on, as opposed to what would normally happen in a as opposed to what would normally happen in a 3D runner game. You can see that the player is going through the obstacles here. So what we want to do, let's create a new script. And we call that script obstacles. So we open up our script. Okay, so what we're going to do here is we need a variable type of player movement. So we're going to create a new variable, call it player movement. Then player movement, let's see, player. Then in our stats, we declare it to say player movement is equals to the game object. Then find type, then player movement. Then this is colon. So now what this does is it searches for an object of the type player movements. So after this, we create a new function, and we on collision enter. So on collision exits is for when the player leaves the platform. On collision enter is for when the player touches the obstacle, in this case here. So it's called when two obstacles collide. So now what we want to do is we want to kill the player. We want the player to die when touching the obstacle. We want the game to stop when the player touches any of the obstacles. So what we do is we go back to our player movement script, and we create a bool to acknowledge that the player is alive. We say a bool alive equals to true. So Boolean alive equals to true. In our fixed updates, we are going to add a condition. So if not alive, that is, if our player is not alive, return. Player is not alive. Return. Okay, so this is basically saying that if the player is not alive, they cannot move. So everything that comes after this will not run. So we create a new function, and let us call a public void. Name it die. Very precise. Then what we want to do is, since we'll be using a scene one, we want to reload the scene, restart the game when the player dies. So we had to add a new using statement here. So we say using Unity engine scene management. Okay, good. Let's get started. So back here in our die, we see alive is equal false. Then we will restart the game. Using comments makes it easier to script and understand what you are scripting for. So now we say scene manager dot load scene, then brackets scene manager. So we want to get the active scene. We're looking to get active scene to query, then dot name. Okay. Now what this does is it loads the screen that we are currently in. The game will restart. So let us go ahead and save this. I'll go back into suppose. Okay, wait a moment. I'll save this and check out our results in Unity. So let's check this out. Additive widget body and prefabs obstacle. Okay. So here we add a widget body. Yeah, perfect. So let's play our game and see how it works now. It appears I have not added the obstacle script to our obstacle. So go to our prefab, about obstacle. Yeah, okay. Then click on it, add components, scripts, call it obstacle. So let's run this now and see how it works. But we did not check if the objects we collided with was a player. We did not check if the object we collided was a player. So what you are going to do now is you are going to go back into our obstacle scripts. So our scripts, obstacles. Then we check if the object is so in our if. So let's do this. So if collision game object dot name is equals to player, then kill the player. So here we say player plus movement dot die. That's about script. See how it works now. Okay. As you can see, as we hit an obstacle, the game restarts at every point we do. Yeah. I'm playing on, let's see, as we hit an obstacle, the game restarts and what to do. So now let's check out something. I'm going to give you a mini assignment here. So we notice that when the player falls off the platform, the game continues as going on. So I want you to add for your first assignment, I'm going to provide all the scripts I use. You have to edit or manipulate the script to make sure that after the player falls a certain height, the player dies too. So now we notice that the game is like rapidly starting. So it would be better if we had like a delay between hitting the obstacle and when the game actually restarts. So to do this, let us open a player movement script. Then under our die function, we look at it, move. Okay, we create a new function for a restart. So we call it a void, and we name it restart. And our parentheses. And let's remove this entire script here. And scene manager here. Okay. Scene manager. So remove this entire thing here, and underneath here, what we're going to do is we're going to invoke the restart. We're going to call the restart, but with a delay. We're going to call the restart function and assign the period of time we want the delay to occur. So I'm going to say invoke the die function, invoke, then in bracket, restart. Then comma, and after, let's say 1.5 seconds. Okay, 1.5 F since we're looking at the float. So go ahead and save our scripts. Then let's try it again. So you can see that after the object hits it, there's a slight delay, then it restarts. There's a slight delay, then it restarts. So I think the game is moving too fast. Yeah, so we go into our player, then we could easily reduce the speed here to 8. That's fine. Yeah, so let us create a material for the obstacle. So we open our materials, create a new material. We name it obstacle underscore material. Then here in our video, we make it red since enemy. Then let's open our prefab. Then open our obstacle prefab. Then to our materials and extract this there. So good. Let's see how this looks in the game. Okay, there's a delay. Another delay. Okay, good. So our game works well. Our game works well. So what I want to do, I don't like this skybox here. So we go to our main camera, then we change this from skybox to a solid color, and let's pick something a bit warm. I think this is good. And let's see how the game looks now. Start. Okay, this is better. This is good. Okay, that's fine. So finally, what we want to add to this game to make the experience more desirable is coins. We want to create this sort of a coin counter, a points counter for every coin picked up. So let's do this quickly. First thing we're going to do is we're going to create a 3D object, and we'll be creating a cylinder, name it coins. Let's reset the transform. Okay, yeah, that's good. Reset the transform, and on the scale, we scale it down on the X to 0.7. On the Y, we'll be working with 0.05 because we want it to be flat. Then hold on, let me zoom in here. Okay. It to be flat. And on the Z, we scale it 0.7 as well for uniformity. Okay, that's fine. Then after that, we rotate it 90 degrees on the what axis? Say on the Y. We say no, sorry. It's on our Z axis, rotate it 90. That's fine. Cool. Now let's create a material for the coin. Now material, we come here and say create create a new material and we say coin underscore material. I'm going to provide the GitHub link for this file, the project in that file after to have a goldish color. I'm sorry about that. I want it to have a goldish color. So let's see, is this fine? Okay, I think this is fine. Okay, good. It's fine. Yeah, so that's good. Just assign it to the coin. Good. So we in the collider settings for the coin, since we'll be interacting with it mostly, we want to click on each trigger. We're going to be working with that later. So next up, we go to our scripts. We create a new C# script and we name that script. Let's call it coin. Just coin. Just coin. Yeah. So let's open up our scripts. That's outside. Let's hold on for it to open. Okay, open up our scripts. Then first of all, we're going to create a new function. So it's going to be a void on trigger enter, on trigger enter. Okay. Void on trigger enter. So we're going to do three things here. Right? So we want to check that the objects has collided. That is, the object has collided with the player. Let's check that the object we collided with the player. Secondly, we want to check. Let's add to the player score. And thirdly, we want to destroy the coin after the player has touched it. So we say destroy the coin. So first off, we want to check if the player what we collided with is the player. So what we are going to do now is we are going to use an if statement if, that is other, to access other game objects outside the script. Other game object dot name is not equals to player. Then we're going to put return. So basically, this is saying that if the object that we collide with is not the player, then it will stop executing the rest of the body of the code over here. So next up, we want to destroy the coin. So let's go here. This is easy. So I'm just going to destroy bracket game object. That is to notify the game object here in small caps. It's just to notify us that it is the coin that will be destroying. So obviously the coin cannot be in a single position. So we want the coin constantly rotating about an axis. So let's create a new variable. Okay. New variable and we call it transpeed. So we say public. So we can see it in the editor, float speed. That's equals to 90f. Okay, good. So in our update method, our function rather, we transform. We want to rotate it. Let's rotate. Then the axis will be rotating it by, so say 0, 0, then our turn speed. That's why C wants to rotate about our Z. So our turn speed multiplied by time dot delta time dot delta time. Save our script. Then when the script is saved, it's compiling. So we drag our coin onto here. So what I want to do, I want then let's drag the coin into our prefabs folder. Put a coin into our prefabs folder. Then we delete the one present in the scene. So now we've created the coin, we've added the rotate function. Now we want to spawn those coins. We want to spawn the coins. So first thing we want to do is we go into the ground tile script. Go into the ground tile script. Then we create a new variable called a public object, and we call it a coin fab. Yeah, so after this we create a new function. Let's create a void, then we call it spawn coins, parentheses. So here we want to set an integer for how many coins we want to spawn. So let's comment integers. So say integer for number of coins. So we say int, then coins to spawn 10. Good. So now next up we're going to use a for loop, just so we don't have to call this ourselves. So we say a for, let's say for total for, then we change this length to coins to spawn. So coins to spawn. Then it spawns one coin. So we're going to, then let us add a comment to spawn the coin. Next up, usual, we're going to instantiate. So you say instantiate and spawn coin prefab, close it. So we need to get a reference to the coin we just spawned so we can change its position later. So we're going to do what we did earlier. So we add this a game object, we're creating a game object. So the game object and temp, the temporary variable equals to this. Now, what this does is that it stores the newly spawned object into that variable temp, the temporary variable just created. So after this, what we're going to do is, because like this, we're going to create a new function, and it's going to be called a vector3, then get random point in collider in brackets collider small collider. Good. Then our curly braces. So what we're going to do is we're going to use collider bounds. That is, we want to know how far each collider reaches. I already calculated this, so we're going to create a vector3. Vector3, and we're going to call it point equals to the new vector3. Then parentheses. And let's do this. So we're going to open this out. It's going to be long. We're going to get 3 coordinates of x, y, and z. That is acknowledging the minimum coordinates of x on the collider, minimum coordinates of the collider on the x, minimum on the y, and minimum on the z. Then sorting those into 3 different coordinates, x, y, and z. So as I do it, it's going to make sense. So we're going to open this bracket so the code is more readable. So what we're going to do first is we're going to create a random dot range collider dot bounds dot max x, the minimum rather, this minimum of x, minimum dot x, comma, collider counts maximum of x, and close the bracket. So what's after this? We're going to see a comma. So yeah, a comma. So we want to do this for the y and the z axis. So we just need to copy and paste this. So Ctrl C and paste it. So for the y, just change x here to y. So it's getting the minimum boundaries for the prefab we created earlier. So finally, we create this one and we name it to z. Yes, perfect. Then delete this and close the bracket. Perfect. So after this, we are going to create a condition. We're going to create a condition after creating this. So after this, to say if point is not equals to the collider, those process points to collider, point is not equals to collider process points, then in brackets the name of the variable created earlier points. Then we want the point equals to get random points collider. And this is collider. So now what this does is that it checks if the random points we generated is on the collider, and if it is not, a new variable will be generated that is inside that collider. So after this, we're going to say point y, point on y. We don't want the points moving anywhere on the vertical axis, equals to 0. This was to 1 rather. And that is coins that spawn will spawn on the same height, and finally return point script now. So what we're going to do now is back in the spawn cons function. So look for the spawn coins. So back in this function, what we're going to do is we're going to add a temp. So we're going to say temp temporary dot transform, the variable we created earlier, using the transform and the position, storing the get random point in collider, and brackets get component get component. And component name is collider. It's capital COL. And afterwards, we close it with our parentheses and close this up. So now what this does is it sets the position of spawn coin to a random point in the collider. So let's go ahead and save our scripts. Then finally, we'll soon be done. This is a strenuous process. So back in the start function of our ground tile script. So back in the start function, we would spawn coins. Spawn points, then close our parentheses. So let's see. Then control Let's go ahead and save our script and open Unity. Okay, let's run our game and see how the coins spawn. It seems like I haven't. So let's go back to our prefabs coins. Okay. Awesome. Okay. I'll open our ground tile prefab. Ground tile. Then you can see that the coin isn't assigned yet. Then you just assign that's here. Okay, let's see how it works now. So now we can see that our coins are being, sorry about that. Okay, so you can see that coins are being generated randomly. So another part of your assignment would be to destroy these coins when the player collides with them. As you can see, it's just picking up coins. Okay, they're going to create a counter, and we can also see that the coin is spawning inside the obstacles themselves. So your assignment would also be to stop that. I'm going to provide the scripts and the project file for this game after the class. So I can see that our time is almost up. So if anyone has any questions on what we've been doing so far, does anyone have any questions? Okay, it seems there are no questions. So it's almost 6 o'clock. I'm going to be sending the project file, the scripts, and the assignments you are meant to do to the Slack group immediately after the class. So yeah, since there are no questions, we can call it a day.
Hello, Samuel. Can you hear me?
Yeah.
Hello, Samuel. Okay, cool. All right. Okay, thanks a lot for the class. Really helpful, really technical. I will stop recording right now and we'll drop in the assignments today. And what's the deadline for the assignments? Let me stop recording. Wait, just wait. When is the deadline for assignments?
I'm thinking Wednesday.
It will be next week Friday. Yeah, next week Friday. So let's try to get assignments in by then. And we'll see you guys. All right. So bye everyone. Bye Zeno.